Students, now I'm going to discuss about Legendre's linear differential equation. What is the general form of Euler-Cauchy's linear differential equation? What is the general form of Euler-Cauchy's linear differential equation? X power n into d power n, and the coefficient is some constant pn plus pn minus 1 into x power n minus 1 into d power n minus 1 plus and so on, plus p2 into x square into d square plus p1 into xd plus p naught of y is equals to q of x. This is a general form of a Euler-Cauchy's linear differential equation. But here I'm going to give you one more point. In this differential equation, where is x is there? The coefficient of d. Here x is there. Here we have x. Here also we have x. So d square coefficient, d coefficient, d power n minus 1 coefficient, d power n coefficient, all are in functions of x. But in place of x, if we are having a plus bx, so what is that? A plus bx. Then what is going to become? I'm rewriting it. So pn into x power n. Instead of x power n, what I mentioned? Ax plus b whole power n d power n plus pn minus 1 into what we have to write here in place of x? Ax plus b whole power n minus 1 of d power n minus 1 plus and so on, plus p2 into x square. In place of x, what we discussed? Writing ax plus b whole square. Square is already there. Okay, d square plus p1 of x. In place of x, what we discussed? What I mentioned? Write down ax plus b of into d plus p naught of y is equals to, right hand side should be in functions of x only. I just mention only left hand side part. This is the thing. An equation in this form is said to be Legendre's linear differential equation. So this is just a Euler differential equation. So this is not required. I hope you understood why I have written the first equation. The first equation I have written only because of our Legendre's linear differential equation and our Euler-Cauchy's linear differential equation, both are same, but in the left hand side, in place of x, we are going to get simply, what is that? In place of x, we are going to get ax plus b. That is a concept. So here now I am explaining an equation of the form pn into ax plus b whole power n into d power n, pn minus 1 into ax plus b whole power n minus 1 into d power n minus 1 plus and so on, plus p2 ax plus b whole power 2 d square plus p1 into ax plus b. This is p1 into, not p1 of. Okay, so p1 into ax plus b into d plus p naught of y is equals to q of x. An equation of the form is said to be called as Legendre's linear differential equation. And what about this differential equation? It is a linear differential equation with variable coefficients. Okay, and it is a linear DE with variable coefficients. This is the step which I am giving for the purpose of we have to convert a linear differential equation with the variable coefficients to with the constant coefficients. Yes or no? With the variable coefficients. Now I'm taking this as equation number 1. How to convert it into a linear differential equation with variable coefficient to linear differential equation with constant coefficients? We discussed in the last class as we have to substitute. What we have to substitute? Put x is equals to what? E power z. But in place of x, what we have here, it is ax plus b. So we must substitute ax plus b is equals to e power z. So this is important. In the previous method, in place of x we substituted e power z, but here we have to substitute in place of ax plus b, we have to substitute e power z. That implies z is equals to log of what we are going to get? Log of ax plus b. This is the thing. Now what we discussed earlier, and we substituted x into d is equals to theta earlier. Same manner, x square d square equals to theta into theta minus 1. But here we have to substitute a in place of x, we are substituting ax plus b. So ax plus b into d, we have to substitute. It is equals to not simply theta, it should be a into is equals to a into theta. It should be a into theta. What is a here? The coefficient of x. Same manner, we have to substitute ax plus b whole square into d square is equals to, we have to substitute what we discussed earlier, previous formula, a into theta. But here a into a is only for one theta, another theta minus 1 is there, so we have to multiply with a square. And same manner, we have to substitute here. What is the next term? Ax plus b whole power 3 into d cube is equals to, what we have to substitute according to earlier case, x cube d cube equals to theta into theta minus 1 into theta minus 2 only. But here in place of x, we are having left hand side ax plus b, that is ax plus b whole cube into d cube is equals to a cube into theta minus 1 into theta minus 2. Okay, so and what is d here, where d equals to, what is that? As usual, d by dx. And what is theta? As usual, d by dz. So we have to continue substitution of ax plus b into d is equals to a theta, ax plus b whole square into d square equals to a square into theta minus 1, ax plus b whole cube into d cube is equals to a cube into theta minus 1 into theta minus 2, and so on. Like this we can continue. And substituting all these things in equation number 1, what is going to become? What it's going to become? By substituting all these in equation 1, then it reduces to what is that? A linear DE with the constant coefficients. With the constant coefficients. With constant coefficients. That one only we discussed. What is a given linear differential equation? Is a linear differential equation with variable coefficients. That equation converts to, by substituting all these things, it's going to convert to a linear differential equation with constant coefficients. What is the general form of linear DE with constant coefficients? It's going to get, that is f of theta of y is equals to q of z. Q of z. Taking this as equation number 1. Solve equation number 2. Solve equation 2. And then what we have to do after solving this? And then replace. What we have to replace? E power z equals to x plus b. And same manner, z is equals to log of ax plus b. These are the things. And then replace these other things. Then we get general solution of the given differential equation. Is it correct? then we get general solution of a given differential equation. Given Legendre's linear DE. Legendre's linear DE. Okay, so this is a procedure. Now I'm going to discuss one problem on this. Only one problem I'm going to discuss, and it is very, very important. So many number of times this is a problem given in the last year mid examinations as well as external examinations. So I discussed the same problem for the students, and the same problem is given by given the both the question papers. If you feel so, this is a given differential equation for us. X minus 1 whole cube into dqy by dx cube plus 2x minus 1 into dy by dx minus 2y is equals to x. Left hand side, in wherever we are having x, it is in the form of ax plus b form. So, what is a given differential equation? Is a Legendre's linear DE. So, I am writing given differential equation is writing the differential operator form of this equation. So 2x minus 1 whole cube into d cube plus 2x minus 1 into capital D minus 2 of y is equals to x is equals to x. Taking this as equation number 1 is a Legendre's linear DE. Legendre's linear DE. So, if it is a Legendre's linear DE, what we know according to the procedure, we have to substitute something else. So, what we have to substitute? Put ax plus b equals to e power z. So, what is ax plus b here? 2x minus 1 is equals to e power z. That implies what is z? Log of 2x minus 1. Just for our future reference, this is also I am writing it. But here, how we can write this one? How we can write this one? From this, can we write 2x is equals to, I am taking minus 1 to right hand side. It will become plus 1, 1 plus e power z. That implies, what is x can be written as 1 by 2 into 1 by 2 into 1 plus e power z. Is it okay? Understanding everybody? Why I'm writing this is, this one we do not directly x is equals to e power z is there in the previous problems. But now x I am writing in functions of z. Now you check here in the right hand side of this x. Right hand side is everything is in functions of z only. Yes. So this I am going to substitute in equation number 1 in our right hand side part. So then it will be useful for us. Okay. Now going to our few more substitutions. According to the procedure, after we have written these 2 points, what are the few more things we need to write? And x into d equals to theta in our Euler-Cauchy method. But here 2x minus 1 into d is equals to a square. What is ax plus b into d? In that a, here it is 2. So we have to substitute a into theta, nothing but a value is 2 into theta. I hope you are understanding. Any doubt are there? Then you can unmute and you can ask immediately. Same manner, 2x minus 1 whole square into d square is equals to 2 square into theta minus 1. And same manner, 2x minus 1 whole cube into d cube is equals to, we have to substitute d cube into theta minus 1 into theta minus 2. Okay. So now if we observe in our problem, they given cube term and also power 1 term. So I'm not simplifying the square term here, but I'm going to simplify this cube term. If we simplify this, what is going to become? What is going to become? 8 into theta into, what is the theta minus 1 into theta minus 2? Theta square minus 3 theta plus 2. Multiply with this 8 theta, what it's going to become? 8 theta cube minus 24 theta square plus 16 theta. This is the value of 2x minus 1 whole cube into d cube. Okay, this is the thing we required to substitute in our problem, and this is also required to substitute in our problem. That means in our given problem. And what is d here? Where capital D equals to d by dx, and theta is equals to, as usual, d by dz. Now we are going to substitute all these things in equation number 1. Substituting all these things in equation number 1. So writing that step, substitute all these in equation number 1. That implies, what is equation number 1? We have 2x minus 1 whole cube into d cube, first term. So what is the 2x minus 1 whole cube into d cube? We have here 8 theta cube minus 24 theta square plus 16 theta is the first term, plus, what is the second term of that? 2x minus 1 into d, and then minus 2. What is the 2x minus 1 into d? 2 theta. And then minus, what is the third term? Is 2 of y is equals to x. But what is x we got here? What is x we got here? 1 by 2 into 1 plus e power z, which I marked with the green color. 1 by 2 into 1 plus e power z. So 1 by 2 into 1 plus e power z. Now, doing the simplification, the left-hand side part, what is the highest power of theta? Theta cube. So what is that coefficient? 8 theta cube minus 24 theta square plus 16 theta plus 2 theta. It becomes plus 18 theta. All of you take your scientific calculators. Minus 2 of y is equals to 1 by 2 into 1 plus e power z. Now, taking this as equation number 2. What is equation number 2 is a? What is equation 2 is a? Is a linear DE with the constant coefficients. Check it, yes or no? With the constant coefficients. With the constant coefficients. That is the thing. Now, what is with the constant coefficients is nothing but how it looks like. That is f of theta of y is equals to, f of theta of y is equals to q of z form. Okay. What is the general solution of equation number 2? Then its general solution is, general solution of equation 2 is what's the general solution of equation number 2? Y equals to yc plus yp. But what about yc and yp are in functions of z variables? Because why? Our equation number 2 is in functions of y and z. In place of x, we are having z. So because of that reason, yc and yp will be in functions of z variables. In functions of z variables. Now we need to find the yc. For finding yc, what we need to consider? Auxiliary equation. So I'm putting like a small side heading, finding yc. But I did not use this heading anywhere in our previous method. That means previous method means our last method, finding yc. It is not mandatory to write, but still I'm writing this is only for the purpose of you can understand. It's like a coding. Okay, step 1 is finding yc, step 2 is finding yp, and then adding yc and yp, we are going to get the general solution. Then consider auxiliary equation to find yc. What is the auxiliary equation? F of m equals to 0. What is m? in place of f of theta, in place of theta we have to substitute m. So what we'll get finally, 8m cube minus 24m square plus 18m minus 2 is equals to 0. Now tell me how to find the roots of this cubic equation. So use your scientific calculator. In your scientific calculator, you change your mode it into equation and then use the cubic equation. That means polynomial equation. Yours is class base, okay? Class base scientific calculator you are using. So take with the polynomial. What is the order of the polynomial? 3. What is the coefficient of m cube? Is 8. Next, x square coefficient, that is m square coefficient is minus 24. Then m coefficient is 18. And then what is the constant term? Don't say it is 2, it is minus 2. Then if we find, tell me what are the roots we are going to get? M is equals to
2 minus root 3 by 2.
2 minus root 3 by 2.
2 plus root 3 by 2.
That means 2 plus or minus root 3 by 2. Okay, one, next one, and also
1, sir.
1. So
1.
total 3 roots, you got it. Okay, so this is important. Now I am taking 1 as a first root. Then what is yc is going to become? Therefore complementary solution yc is equals to c1 into e power m1. What is the m1 value? Is 1. So e power z plus, okay, wait, I am writing the roots like this, 1 and 1 plus or minus root 3 by 2. Can I write like this? Now I'm going to use these are the things. Okay, so whenever first one is the root, then c1 into e power z, and the second root is a plus or minus root b form. What is the b value? 3 by 4. But here root b value is root 3 whole by 4. Root is only for numerator. So here we are getting the surds. Then when we get the surds, what are the solution we are going to get? E power a into z, that is e power z into c1 already completed, c2 cos h into root 3 by 2 into z. Root is only for 3 but not for 2 and z, plus c3 into sin h of root 3 by 2 into z. And taking this as equation number 4. Equation number 4. Not going to do any simplification because everything is clear only. Now what we need to find? We need to find yp. While finding yp, what we have to consider? Okay, I am writing as finding yp. Finding yp. While finding yp, we have to take, what is the general form of yp? 1 by f of d of q of x, but here it is 1 by f of theta of q of z. Q of z. That implies yp is equals to 1 by f of theta. What is 1 by f of theta value? What is the theta value? 8 theta cube minus 24 theta square. 8 theta cube minus 24 theta square plus 18 theta, I think minus 2, plus 18 theta minus 2 of what is the q of z? We have 1 by 2 into 1 plus e power z. Am I correct? 1 plus e power z. So we have to separate the right hand side. There is a q of z into 2 terms. So 1 by 2 is common for both. 1 by 2 into, okay, using the braces. What's the first term is going to get? First term writing with one color, and the second term I'm going to write with another color. Okay, 1 by, so what we'll get? 8 theta cube minus 24 theta square plus 18 theta minus 2 of what is the first term? How we can write 1 plus e power z as e power 0z plus e power 1z? Yes or no? So we are able to write like this. The first term is e power 0z plus, going to write the second term. What's the second term? We'll get second term also same, 1 by 8 theta cube minus 24 theta square plus 18 theta minus 2 of e power 1 into z. Now, if we observe, the first term is in the form of type 1. The second term is also in the form of type 1. So, using our procedure of type 1, what we have to substitute here in the first term? What we have to substitute in the first term? This is the first term. E power 0z is there. What is the value of a z coefficient? Here it is e power 0z.
Theta equal to 0.
Theta is equals to 0. But we have to substitute theta is equals to 0 in the first term. But what we have to substitute theta value in the second term? Theta value in the second term, 1. If we substitute theta equals to 0 or theta equals to 1, are we going to get 0, the denominator part? How to check? Generally, we have to substitute and we have to do it. But still, we got m values. What are the values of m we got? Is it we got m equals to 0 or m equals to 1? Is a root of m? Yes, we got m is equals to 1. So, because of that reason, for the second term, what we are going to get? For the second term, what we are going to get? 0. If we substitute theta is equals to 1. So, because of that reason, what we need to do here? We should not substitute theta is equals to 1 in the second term. So, because of that, what we have to substitute? What we have to do in the second term? We have to do differentiation. So, first term I am substituting. Let me check what is going to become. 1 by 2 I am, okay, 1 by 2 of, okay, better I'll separate 1 by 2 for both the terms. 1 by 2 into 1 by, if we substitute theta equals to 0, what is we are going to get? Denominator? Simply minus 2. So better I'll write is 8 into 0 power 3 minus 24 into 0 power 2 plus 18 into 0 minus 2. This everything is denominator part of e power 0z. Nothing but e power 0 I am writing. Plus 1 by 2 into, here what we discussed, we have to do differentiation. Okay? Yes or no? So, where we have to write the differentiated one? Denominator only. So, 1 by, what is the differentiation of 8 into, what is the theta cube differentiation? 3 theta square. 3 theta square into 8 is, can I write 24 theta square? Minus 24 into, theta square differentiation is 2 theta. So, 24 into 2 theta is 48 theta. Plus 18 into differentiation of theta is 1. So, that is only 18, that term. Minus 2 differentiation is 0 of e power z. Okay, but here we differentiated denominator part. Then what we have to do according to our procedure? What we have to do according to our procedure? When we did the differentiation, what we have to do? Immediately we have to multiply the numerator with x as a prefactor. But here in place of x, what we are using? Z. So multiply with z as a prefactor. This is important. And then substitute theta is equals to 1. If we substitute theta is equals to 1, we are going to get, okay, so the next term will be 1 by 2 into 1 by minus 2 into e power 1 is e power 0 is 1 plus z by 2 into, so substituting theta is equals to 1 in denominator. Then it will become 24 minus 48 plus 18 only of e power z. So we are going to get in a few seconds our yp. So minus 1 by 4, sorry, minus 1 by 4 plus z by 2 into What is the denominator part we are going to get? 24 minus 24. Sorry, minus 48 is minus 24. Minus 24 plus 18. Minus 24 plus 18 is minus 6. Minus 6 into e power z. So if we do the simplification, then we are going to get yp is equals to minus 1 by 4 minus z by 12 into e power z. This is our yp. This is our yp. Okay. This is the thing we got. Now we have to take it as equation number, I think 5. So we used earlier 4. Okay. Now I am going to substitute all these things in equation number 1. Substitute all these in equation number, sorry, not equation 2, equation number 3. That implies, what is equation number 3? Y equals to yc plus yp. But what is a yc? That implies y is equals to, what is yc? c1 into e power z plus e power z into c2 into cos h of root 3 by 2z plus c3 into sin h of root 3 by 2 of z plus yp. Yp is minus 1 by 4 minus z by 12 into e power z. So this is the general solution of which equation? Equation number 2. What is equation number 2 is? Equation 2 is a linear differential equation with the constant coefficients. This differential equation, solution of this differential equation. Okay, but what we need to find? We need to find the general solution of given differential equation number 1, which is a Legendre's linear differential equation. How to get the general solution of the given differential equation number 1? We have to replace, what are the things? Replace e power z. What we have taken, e power z equals to ax plus b. What is ax plus b? Here it is 2x minus 1. This one. And what is z from this? Z is equals to log of 2x minus 1. Log of 2x minus 1. These are the things. Clear? So these are the things we need to substitute. So if we substitute these are the things here, what is going to become our equation? That implies y equals to c1 into, what is e power z value? 2x minus 1 plus e power z is again 2x minus 1 into 2x minus 1 into c2 into cos h of root 3 by 2 into z. Z is nothing but log of 2x minus 1. 2x minus 1. Okay, brackets for this plus c3 into sin h of root 3 by 2 into z. Z is nothing but log of 2x minus 1. Okay, brackets for this and close the bracket also. Minus 1 by 4 into minus 1 by 12 into z. Z is nothing but log of 2x minus 1. E power z is nothing but 2x minus 1. So we can write it as 2x minus 1 into log of 2x minus 1. So we got the solution is in terms of x and y variables. Am I correct? So this is the general solution of given differential equation. Is general solution of given differential equation. Clear, students? This is the end of the problem. Wait. Formulas of inverse operator. Inverse operator. In this next 5 minutes, we are going to finish this unit. Formulas of inverse operator. What is we discussed? D is nothing but, I'm giving like a general way. D is nothing but d by dx generally. And what is 1 by d is nothing but we discussed as integration of dx. Okay, this is the thing. But now here, what they're asking is, they're giving the formula like this. First formula is this is the basic formula. 1 by d minus a of q of x. For example, it is q of x. Then it can be written as the formula of this one is equals to, the formula of this one is equals to e power ax into integration of q of x into e power minus ax into dx. This is a formula. Q of x may be anything, e power x or sin ax or cos ax or x power m or a polynomial in functions of x, or it may be x into v of x form or e power x into v of x form, or it may be tan theta, or that means tan x, or secant x, cosecant x, 2 by 1 plus e power x, log x, anything. Q of x may be anything. This formula is applicable. This formula is applicable. That is very important. It is very important. Okay, but this formula, why I did not discuss is, whenever q of x is equals to tan ax, then if you observe this one, integration of tan ax into e power minus ax, can we find the integration value? No, it is very difficult to find it. It is very difficult to find it. Because of that reason, we did not discuss. Clear? So this is the only one formula which we are going to use in our problems. Okay, better I'll take one more. 1 by, be careful students, this is d minus a. If it is d plus a, then e power minus ax into integration of q of x into e power ax into dx, we will get it. That is a process. And one more formula, for example, if the denominator is like this, d minus alpha, okay, d minus a into d minus b of, if we have q of x same manner, then what we have to do is 1 by a into b of something is there, then we can write it is as 1 by d minus a into 1 by d minus b of q of x. After we complete this, how to write 1 by d minus b of q of x? Same manner, using our first formula, e power bx into integration of q of x into e power minus bx into dx. Then whatever we get here inside the brackets, this everything we have to take as q1 of x. Then 1 by d minus a of q1 of x. Then we have to continue with the same process. There is a process. Okay, so I'm just giving only the basic concept. If you want, you can check here. I'll explain with a problem. Now here, so here I'm taking a problem just for the namesake. Problem number 1, evaluate 1 by d plus 1 of x. What is the actual process we did earlier? 1 by f of d of q of x form, type 3 we applied. Okay, that is the process. But now here, which process we are going to do here? This first formula is equals to, how we can write, what is the value of a here? It is minus 1. So e power minus x of integration of q of x is nothing but x into e power, a value is -1, minus of -1 is plus x into dx. Okay, what is the integration of, okay, e power minus x into, what is integration of x into e power x? X into e power x minus e power x. This already we are having the formula using integration by parts. If we do the simplification, what we are going to get, the first term is x into e power minus x into e power plus x is 0, minus, what is the second term is going to get? Minus 1, e power 0, nothing but 1 only. So this is the value of 1 by d plus 1 of x. This is the process, but we will do the same problem with our process. What is the general form of our process? Our procedure. Till now we discussed like this. So what is that? 1 by d plus 1 of x is equals to, how we are writing this? Taking this one to numerator, then it will become as 1 plus d of whole power minus 1 of x. That one only, because 1 plus phi of d or 1 minus phi of d form. So what is the differentiation of x? 1. Differentiation of x is 1, but second derivative is 0. Okay, and the third derivative is also 0. So because of this reason, we have to expand the 1 plus x whole power minus 1 formula up to only whole power 1, which is equals to 1 plus x. Whole power minus 1 is nothing but 1 minus x. X is nothing but d, plus and so on, rest of the terms of x. Now multiply each and every term with x. So first term becomes 1 into x is x, minus differentiation of x is 1, plus remaining terms will become zeros. So final answer is x minus 1. We got the same answer even in using that formula. Okay, so this is the end of our unit. Any of you are having any doubts, then you can ask. Otherwise, sorry, otherwise